Bismillahirrahmanirrahim. Assalam O Alikum. Dear student, welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus Physics SSC2 Punjab textbook Lahore. Today we will solve unit number 12 geometrical optics according to SLO base or FBISC requirement according to board exam numerical problem question number 9 to 12 in part 3. In question number 9, given statement, an object 10 centimeter high is placed at a distance of 20 centimeter from a concave lens of a focal length of 15 centimeter. Calculate the position and size of image. Also state the nature of image. Now, according to the statement, first of all, write the given data. In given data, size of an object is equal to h naught, that is equal to height, so that is equal to 10 centimeter. So size of object is equal to h naught, that is equal to 10 centimeter, and the distance of object, that is equal to distance of object is equal to p, that is equal to 20 centimeter, and also given that focal length of concave lens. So here lens is a concave, so focal length is negative. Then focal length f is equal to minus 15 centimeter. Now required that calculate the position of image q and also calculate the size of image hi, and in the last state the nature of image. Now first of all, using the formula, so in A part we use the formula 1 over f is equal to 1 over p plus 1 over q, and to find the image size then we use the formula hi over h naught is equal to q over p. Now in a solution, using the formula 1 over f is equal to 1 over p plus 1 over q. Now putting the value, then 1 over q is equal to minus 1 over 20 minus 1 over 15. Now taking the LCM, here LCM is 300, then 1 over q is equal to minus 20 minus 15 divided by 300. That is equal to minus 35 over 300. So taking the reciprocal on both sides, then we have q is equal to minus 300 divided by 35. Here q is equal to minus 300 divided by 35 is equal to minus 8.75 centimeter. Now we can calculate the height of image hi over h naught is equal to q over p. Hi is equal to minus 8.75 divided by 20 multiplied by 10. So calculate the answer, then Hi is equal to minus 8.4.28 centimeter. Then size of image Hi is equal to minus 4.28 centimeter. Now in next question, question number 10, convex lens of a focal length 6 centimeter is to be used from virtual image 3 times of the size of object where the lens is must be placed. Now first of all, given data, according to the statement, height of image is equal to 3 times of height of object. So hi over h naught is equal to 3h naught divided by h naught, that is equal to q over p. Because hi over h naught is equal to q over p, putting the value, Hi is equal to 3H naught. Here H naught cancel out by H naught. This implies that Q over P is equal to 3. Then Q is equal to 3P. Now the focal length F is equal to 6 centimeter. We have required that position of object P. Then we write the formula 1 over F is equal to 1 over P plus 1 over Q. Now using the formula to find the solution, 1 over F is equal to 1 over P plus 1 over Q. Then we putting the value of Q, here Q is equal to 3P, and we take its value will be negative. Then 1 over F is equal to 1 over P plus 1 over minus 3P. Now we find and putting the value of focal length, 1 over 6 is equal to 3 minus 1 divided by 3P. Now cross multiplication, then 3P is equal to 2 multiplied by 6. Then 3P is equal to 12, and 3 is multiplying. On other side it will be divided. Then P is equal to 4 centimeter. Now we will move the next question. In question number 11, according to the question number 11 statement is given that a ray of light from air is incident on the liquid surface at an angle of incident 35 degree. Calculate the angle of reflection if the reflective index of the liquid is 1.25. Also calculate the angle between the liquid and air interference. So first of all, write the given data. According to the statement, angle of incident theta I is equal to 35 degree, and angle of reflective index n is equal to 1.25. Now we have required that the angle of reflection R, and we also calculate the critical angle theta C. So we can use the formula by the Snell's law, n is equal to sine angle I over sine angle R, and also use the formula n is equal to 1 upon sine angle C. Now to find the solution, putting the values in the solution, then we know that n is equal to sine I over sine R, then putting the value of I, then sine 35 divided by value of n 1.25 is equal to sine R. So sine R is equal to 0.46456. Sine is taking on other side, it will be inverse. So angle R is equal to sine inverse of 0.456. Now angle of reflection R is equal to 27.13 degree. Now we can calculate the critical angle. N is equal to 1 upon sine theta C. Then sine C is equal to 1 upon value of n 1.25. Now 1 divided by 1.25, that will be equal to 0.8. Sine is moved on other side, then angle C is equal to sine inverse 0.8. Taking the sine inverse of 0.8, then critical angle C is equal to 53.13. Now we will move the result. Then according to the statement, angle of reflection R is equal to 27.13 degree, and in a B part, critical angle C is equal to 53.13 degree. Now we will move the question number 12. In question number 12, according to the given statement, the power of convex lens is 5D. at what distance the object should be placed from the lens, and so what will be the real and two times larger images performed. So here write the given data according to the statement. First of all, write the power of convex lens. So power of lens P is equal to 5D and magnification is 2 times larger, then magnification M is equal to 2. Now we have required that distance of object P is question mark. Now we using the formula to find the solution F is equal to 1 upon P. First of all, determine the focal length, then using other formula to find the value of P, that is equal to 1 over F is equal to 1 over P plus 1 over Q. Now in solution we have putting the values F is equal to 1 over P, that is equal to 1 divided by 5 is equal to 0.2 meter. Now this value change into centimeter, then multiply by 100. So 0.2 multiplied by 100 centimeter, that is equal to 20 centimeter. So the value of focal length is 20 centimeter. Now we have write the value f is equal to 20 centimeter to find the value of p. Then using the formula 1 over f is equal to 1 over p plus 1 over q. Now putting the values 1 over 20 is equal to 1 over p plus 1 over 2p. Since q is equal to 2p, here image is 2 times larger and the real image is performed. So we can find the values 2p is equal to 60 and p is equal to 30 centimeter. So the result is that p is equal to 30 centimeter. In next video with next lesson, best of luck. Take care. Allah Hafiz.